Okay. All right, I think we're recording, so let's get started. If any technical difficulties happen, let me know, especially at home if you guys are having technical difficulties. And yeah, let's just start right in on it. First problem here, let's take a look at it. So we're gonna do the first example here, which is 4x squared plus 16x minus 20. Okay, this is my function. This is a lot like what you're doing in your homework for this worksheet you had, worksheet 1.7. Where you're trying to find the roots for your problem. This is the first example out of 4 today, and we want to use the quadratic formula on this. So if you don't remember the quadratic formula, this is the formula we've been using the last couple days in here. X is equal to negative b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. Okay. I had a really good question yesterday. Somebody asked, what happens if your b number is negative? That might be actually one of my examples, and actually might be the third example we do today, so you get to see it. Because I do want to give you one, because that was a great question I had yesterday. When you plug it in, you'll have to change it to positive, because you have to do the opposite of b, negative b plus or minus. So you'll turn to the opposite sign. So I'll turn positive. All right, but let's go through this. So again, up here, if you can see this, what are my a, b, and c number? Which one's A? 4. Okay, what's one's B? 16. And C? Negative 20. It's important that you understand it's just the numbers, like you guys were saying. It's not the variables. It's just the digits that you're using. So that's the numbers I'm going to plug into my formula, right? And then you just type in your calculator and you hit enter and it spits out your roots. That's how simple it is. It's really, there's really no more complicated things. So by plugging these in, I'm going to have, these will find my roots. So it's the opposite of b plus or minus the square root. And now b squared, so my b number is a 16, so 16 squared. And then we're going to subtract 4 times a is a 4, and c is a negative 20. And yes, I have the negative sign attached to it. All divided by 2 times a, and a is a, if I can write that, it does not allow me to write the 2 there. 2 times a, and a is a 4 again. It's really weird, it wasn't letting me touch that one space. Again, this is where you will strongly want to have calculators, because the numbers get so large so quickly that sometimes it's kind of important that you actually do type that in. All right, but again, pick this number just on kind of on purpose so you could see it. Let's kind of go through the math here. So we have negative 16, then we have the plus or minus, now square root. That's 16 squared, 16 times 16. I believe it's a 256. Yeah. Is it? Okay. So it's 256, and then 16 times 20 should be 320. And then, and that's a plus. Now, the reason why it turns out to be addition is because you have a negative 4 times 4, which is negative 16, then times a negative 20, so the negative makes a positive. And then you're going to all divide by 8. So just by looking at this problem does have roots. There's no imaginaries. The reason why is my radical here actually turns out to be a real number. It's a positive number. It's not imaginary where you're trying to take a square root of a negative number. So it is real. It will have numbers. So doing the math here, let me switch up colors so it's maybe a little bit easier to see here. We have x is equal to plus or minus, or sorry, I didn't even put the 16 yet. Negative 16 plus or minus, now square root, this should be 576. All divided by 8. That's the 256 plus the 320. That number is a perfect square. 576, I just happen to know it. It's one of those things like when you type it in a calculator, once you do enough problems, you'll kind of know if it's a perfect square. Again, on your calculator, you're looking for the little square root key. So for mine, it's the little square root key right there. So you're gonna have to type in the square root, and then type in the 576, so it should look something like that. Don't use the other type of radical on it. Make sure you do the normal type of square root, not a cube root or anything like that. And when you type it in, your answer ends up being, and let me switch up colors here, this ends up being negative 16 plus or minus 24 all over 8. So it was a perfect square. And so now this thing actually works out to be really nice numbers, like really nice digits, because of the square root wasn't a decimal. It was a nice clean whole number, an integer. And now we're going to take the negative 16 plus 24 divided by 8, and then negative 16 minus 24 divided by 8. And I believe the two numbers you're getting, if you take negative 16 plus 24, you get, what, 8 divided by 8, which is 1. That's one of the roots, just positive 1. Or if you have negative 16 minus 24, that's negative 40 divided by 8, which is negative 5. All right, questions on the roots that we found. Hopefully at home you guys are seeing that just fine. That's the whole goal, right? That's what we're trying to look for. Where are the roots? Now again, what a root is, if you're not familiar, it's an x-intercept. It's a 0. That's what they call them in the textbook. It's where it's hitting the x-axis. So in the last section we did, the homework that I pushed to today, if you were going to turn it in, is where you had to find, create a polynomial using certain roots, and you had to multiply them together, FOIL it all together. Well, now we're looking at quadratics and figuring out the roots by not multiplying. You're almost kind of dividing things out, even though we're not dividing. So it's just a different strategy. Okay, questions with that first example? Okay, I think we've done enough of these last couple days. Does it seem somewhat familiar? Seem okay? Hopefully at home it does. I want to make this as easy as possible. I don't want you to be lost. That's what I'm fearful of, because I know it's hard learning this stuff from home. So I want to make sure that you guys have time. If you're here in class, you can ask questions and figure out why certain numbers work, that type of thing. We'll get eventually to the last question. I'm going to explain something. I want to show you something that I've hinted at, I've alluded at, but we've never really discussed. So let's get to the second example. Okay, second example today. We're still finding roots, still trying to figure out where it is. Second example here. Let me put it in kind of a different color here. So example, let's go with negative 3x squared plus 6x. That'll be my function, just that. We haven't done one of these yet, so there's a couple things I want to talk about. I want to go through examples of things we haven't really seen yet. This is one we haven't really done. It's missing a term, right? Where we have to rearrange it or fill in a term. What is that number in the back supposed to be? A 0. You can fill that in and then just do the same formula. We haven't really done any of those. It could be any of the terms up here. Maybe the middle term, maybe the x was missing. You can fill in a 0, it's fine. It's just one of those things that I really haven't discussed it, and I thought it'd be kind of important. We probably should. All right, but yeah, so this is the first type, and so let's kind of go through. This is the first one that we've done that we didn't have all the parts to it. So plug in the numbers. This is still my A number. This is still B, and this is still C. So C is a 0. B happens to be a 6, and then my A is a negative 3. So kind of interesting numbers, and we actually plug it into the formula. So here's what we get. We get x is equal to negative 6 plus or minus square root. And then we have what? B squared, so 6 squared. And then we have minus 4 times A. A is a negative 3 times C, which is 0. And this is all divided by 2 times A, and A is a negative 3. So yeah, it's kind of interesting. We have weird zeros. We've never had to deal with that before. It happens. It's fine. We just do it the normal way that we always have. So don't feel like you're doing something wrong. You're not. So we have negative 6 plus or minus. We have 36. And then what's the number after the 36? The negative 4 times negative 3 times 0. This turns out to be 0 back here. And it doesn't matter if it's positive or negative. It's 0. So I don't actually really need that number. And then we're all going to divide by negative 6. So this one turns out to be kind of, dare I say it, almost kind of nice numbers. And so we're getting, a negative 6 plus or minus. Now the square root of 36 is 6, all divided by negative 6. So these are my roots. So the numbers I should be getting here, there's two answers. Remember, you do the negative 6 plus 6 on the top. and you divide by negative. So negative 6 plus 6 is 0, divided by negative 6 is 0. Or, and again, these are the roots, these are the zeros. Or you go negative 6 minus 6, which is negative 12, and divide by, so negative 12 divided by negative 6 is positive 2. So you have two roots. And they're nice clean numbers again. Now, sometimes they work out to be clean numbers, sometimes they don't. I know the last couple days I've done problems where they turn out to be crazy decimals. But sometimes they do work out to be nice and clean like this. Remember, you do have homework. I think I gave you a worksheet on yesterday. It's due on Friday. It's due tomorrow by midnight, so you'll submit it online. You'll just do the work on a separate sheet of paper, or maybe you have a printer and you print it off. But do the work and then take a picture of it and attach that to the Google form, the Google Classroom question. So just attach it. That way, that's how you turn it in. Attach your picture. Okay. Any questions from you guys here or at home? I don't want to talk too much. I know you guys are probably waiting for that third question, trying to get so you know what to fill out for this Google question of the day. Anything that maybe I'm jumping over that you're not comfortable with? Anything really. People at home are very quiet today. Okay, let's get to the third one. This is the all-important one. This is the one kind of everyone's waiting for, I think. Okay, so third question. Let's get rid of the graph. I don't need graphs. Third question is going to be some big numbers. I want you to see something with some large numbers where you have to use a calculator. So third example, this is the one, I'm going to put a little star next to this one. This is my third example, example number 3. This is the one you have to put on the Google form. I want the roots for this problem, so I'm going to put a little star next to it. Okay, here it is. It's negative 9x squared minus 63x minus 108. Big numbers. Big. Right. Now this is the one I brought up earlier. What? And this is somebody had just a good question. I don't even know who asked it yesterday. It was, what happens when the b number is negative? What do you do? Well, this is a good time to look at it. So let me change up the colors here. So again, my a number is a negative 9, my b number is a negative 63, and my c number is a negative 108. So all the numbers are negative. So I still go through the formula the same, right? It's nothing different. Don't suddenly change your strategy. You just want to plug them into the formula. So x is equal to negative b. So a negative 63 is positive 63. So that it's the opposite of b. Plus or minus square root b squared, so negative 63 squared, which is a big number. Big number. I kind of promised you we'd get some large numbers here. And then we have what? 4 times a. Oh, sorry, minus 4. What am I doing? Minus 4 times a times c. And this is all divided by 2 times a, and 2 times the negative 9. Now again, big numbers, right? Okay, so doing some of the math here, we have 63 plus or minus. Now, 63, negative 63 squared, well, it's going to turn out to be positive. Negative times negative is positive. So 63 squared, or 63 times 63 is 3,969. And now this is going to be a negative number here for the number that comes after, because you're actually taking a negative 4 times a negative 9 times a negative 108. There's 3 negatives. You're going to keep the negative sign. So it's going to be 108 times 4 times 9. Yeah, we're getting 3,800. That is weird. Why won't it let me write that 8 in the normal spot? 3,888, all divided by, what, negative 18. 2 times 9. Negative 9, I should say. Okay, is there any questions so far? Hopefully I haven't lost anybody. This is seeming pretty easy. Now, when I subtract those numbers, 3,969 minus the 3,888, I'm getting an 81. That's a super clean number, right? Usually that's how it happens. Like the numbers turn out to be really big. It's probably because they're going to come right back to normal again. And so what we're getting here is we're getting 63 plus or minus 9 all over negative 18. And then you're going to do some multiplying and dividing there. So, or not multiplying, but adding and subtracting and then dividing. Okay, so 63 plus 9, what is that? 72. And then we have to divide by negative 18. 72 divided by negative 18. So one of my answers is negative 4. Or, and again, this is the all-important question. This is what everyone wants to see. It's negative 4 or negative 63 minus 9, which is what? 54. And we divide by negative 18, which is negative 3. Those are my two roots. Again, that was the 63 plus 9 divided by negative 18, or 63 minus 9 divided by negative 18. And that's the all-important question. That's what everyone wanted to know. They wanted to know that. That was the whole point right there, those two numbers. Okay, everyone understand what you're trying to enter in the Google form today? That's the numbers you're trying to enter. All right. We only have one last question. This last question will take me like a minute. There's something I alluded at that I haven't really covered yet, and we're gonna see a different strategy tomorrow. Or we'll do an intro to a different strategy tomorrow. I'm not gonna really go too far in depth on it. Something that I've hinted at, finding roots. For roots, we've taken the back number, taken the front number, set up all those fractions, divided them out one at a time, synthetic divide. That was a tedious process. But we started this chapter with something, we're going to end with the chapter on something. It's on factoring. And I really haven't brought it back up for a very, very long time. If you are really good at factoring, you can find roots quickly if you're really good at factoring. This problem was factorable, believe it or not. I made this problem factorable because if you were to take out common factors and do trinomials, you would have found that the answers would have been the negative 4 and negative 3 anyway. And that's something that we really haven't jumped back to. How do you know if a problem is factorable or not is because of the math we're doing right now. If you were to set up your quadratic formula on a quadratic, and it works out to be perfect numbers inside the radical sign. In fact, I'm going to circle this with my little yellow color. If this number right here turns out to be a perfect square, like every problem I've done today, the problem was factorable in the beginning. I just didn't tell you that. You can break it apart into parentheses and you wouldn't have to do the quadratic formula. You would have got it by just factoring the thing apart. And that's something I've alluded at, but I've never really covered. So I just want to show you on the next one. I'm not going to do the whole, the entire quadratic formula again. I think we've done enough examples of that. But I just want to show you the idea of factoring, right? So let me go to an example here. So let's say we're doing like x to the 4th plus x to the 3rd, right? This is not a quadratic. I understand that. But you can factor it apart. And that's what a root is, right? Roots are things you can factor. So if I could factor this thing apart by pulling out, like they both have x to the 3rd in both of them, and I pull that out, and I divide an x to the 3rd out, so that leaves me with an x in the front right here, and if I pull an x to the 3rd out, that leaves me with a 6. That's factoring, right? And these would be the roots for that problem where it hits the x-axis. That's what factoring does for us, if you can factor. So how this works is whatever the opposite number is in the parentheses, so this would be a negative 6. And if there's any variables on the outside, they have to be any variable at all, it's always a 0. It's always a 0 if there's a letter on the outside. If there's any numbers, you just ignore it. But if it's a variable, it would be 0. That's factoring, right? If you look back at all 3 questions that I did up to the point where you had the Google form question, they were factorable, every single one of them. And those factorings would have gave you the exact same roots as the quadratic formula would have. And that's what I want you to recognize. So that's something that we should always check. Factoring, I know a lot of you hate factoring. It is a solid strategy though. Okay? All right, questions with anything I've done up to this point today? Okay, you're gonna have the rest of the time today. You have about 10 minutes or so, 15 minutes, where you can just kind of work on your homework. Homework's due tomorrow before midnight. It's a worksheet. It's on Google Classroom. I either have the picture of it in case you can't open a Word document, because I know some people have their own personal computer at home, or if you're using your Chromebook and you can't open that Word document, I have the picture there, so you should be able to open up the picture and still do the math. Do it on a separate sheet of paper, take a picture of it, submit it back to me on Google Form, the picture of the work you did, okay? Just attach it and so I can open it back up. But that's due by tomorrow at some point, so you have some time today to work. If you are online, you guys can log off. You guys know your Google question of the day. I'll go right back to it. Here's your answers you're supposed to submit. But thank you for being here, and I will see you guys tomorrow. Same with you guys. Log in tomorrow, same time. I'll send out the links tonight and tomorrow morning. And so you guys are encouraged to be here, because that's how I take attendance. So a couple of people were gone today, so I'm really surprised by that. But if you have any questions, don't be afraid, especially those online. If you have questions, fire away.
I have a question on the homework.
Perfect. Fire away.
Today.
Yeah.
So the last problem. So I got your email, but then I think I messed it up even more.
Okay. So give me that part where you got to before you messed it up, because I did receive an email back to you, but what was the part you got to? Give me the 3 parentheses that you had, or the 4 parentheses you had.
I have x plus 4.
Okay.
X minus 1/3.
Okay.
And then a bracket x minus, and then parentheses -2 plus 3i.
Okay, 3. All right, you can stop there, yeah. And then x minus -5 minus 3i, yeah. Bracket, yeah, same thing. All right, and you had to FOIL these two together, right?
-1?
Yeah, because when you do imaginaries, this is the sign that has to change. Just that one in front of the I.
Well, maybe I wrote the equation down wrong, because I have 3i. I don't have a -5.
Oh, I don't know where I got the 5 then. So, let me fix that, sorry. I must have been thinking about some other problem. What was I thinking of? What I was thinking of. X minus 3i and x plus 3i. Okay. All right. Now, here's to help you out on this one. You're going to FOIL the back 2, right?
Yeah.
So that's x squared plus 3ix minus 3ix minus 9i squared. And what does that simplify into?
The 3ix cancels out, and then -i squared turns into a positive I,
Yeah.
or plus 9.
Plus 9. Okay, I agree with that. 100%. Right there. Okay, now, these up here. This is probably the part I think you messed up the most when I looked at your email. What I would do on this problem, I know this seems a little weird, I would change this parenthesis. Now, how I would change this, because you're right, it was 1/3, right? And you had to put x minus 1/3. Here's how I'd write this problem differently. I'd write it like this. Because that still represents 1/3, if you think about it. And then when you FOIL these together, that way you don't have to deal with any weird fractions.
Yeah.
So, that's just a little hint for you.
So how do you change it into that?
Whatever this bottom number is, just put it in front of the x.
Okay.
That's the easiest way to change it. So if it's a 4/5, just put the 5 on the front of the x, whatever is on the bottom. Does that help you out a little bit?
Yeah.
Okay, good. Yeah, that's an easier way to do it. So.
Okay.
All right. Still sharing, right? Yeah, that's still sharing.
Yeah.
Okay. All right.
So did I do number 28, right?
Let me zoom in. Sorry, I stopped sharing my screen. I got to see your work here. I got to zoom in here so I can see it.
I don't know if I showed you number 28.
So 28, is that what you're looking at? Hold it right there. Don't move. X. Can you scroll over just a little bit? Yeah, I think you did it right. Yep.
Good.
Okay. Yeah, the work that I saw there looked correct. So.
Because it was like this one, so I was like, if I mess this one up, I probably messed that one up.
Yeah.
But I didn't have a fraction, so I was like,
Okay. All right. Anything else I can help you with?
nope.
Perfect.
Thank you.
Yeah, thanks for tuning in.